Good morning, students. Lecture fifth one, and that is the new phenomena, that is the diffraction. In last two lecture, we were discussed interference, and in present lecture, we discuss diffraction. So, this is also a proof of wave nature of the light. Proof of wave nature. Or in other words, you can say that if you take light as a wave, then and then we can explain diffraction phenomena. Proof of wave nature. All type of wave, whether it is a light wave or matter waves or waves propagates on the surface of the water, all show this diffraction phenomena. But in routine life, we can't see diffraction phenomena in light. Why? So, wavelength of light is very small compared to aperture. So, in normal experience, it cannot be seen. Okay, I take very simple example. Suppose I am sitting in the room. If any person outside the room is speaking something, I can hear the sound, but I cannot see. Why? The sound wave has wavelength, you can say 0.5 meter, 1 meter, it may be wavelength of the order of meter. I say of the order of meter. So diffraction is more. And for light, it is of the order of, for light, it is of the order of few thousand angstrom, or you can say 10 raised to minus 7 meter. So sound outside, sound from outside room, we can hear but can't see the source or the person. So this is the reason. Before Young, Newton has also shown that when a light enters in hole, suppose pinhole, then it deviates at the edge. ધાર પાસે શું ત્રાંસા થાય છે. It is called diffraction. When wave, any wave, incident at sharp edge, it deviates from its path. Is called diffraction. Okay, it is called diffraction. And in simple way, if you want to see in your room itself, you take two pen. Better way to take two knife or two blade and you keep this two pen like this. Okay, both must be parallel. Line, this boundary must be parallel, and you bring near, near, and near, and if you see through this, if you at certain distance, you will find some bright and dark bands. You can see it. This bright and dark bands is because of the diffraction phenomena. Because of diffraction phenomena, you can see bands. Okay, તમે ઘરે પ્રયોગ કરી જોવા. XRD, X-ray diffraction, is very good tool to study the structure of the material. In that also, X-ray is passing through that. Electron diffraction, electron is passing through that, and you can get the information about the structure of the matter through which it passes. Okay. In fact, I tell you, that is also described in page number 370. There is a debate between the interference and diffraction pattern. So nobody till today explain what is the exact difference. But you know the scientist Feynman, Nobel laureate, he was a very good teacher also. What he said, if you have two sources, and what we observe is the interference. But if you have many source here, many source, and whatever the phenomena is taking, that is called diffraction. So still answer is unclear, but we are explaining in two different ways. One is interference while taking the two source, and diffraction we take only one source, but it is a wide one. So you can say that when you have two source, you can explain it on the basis of Young double slit experiment. But if you close one, what you observe, that is diffraction. That is diffraction. Okay. So we start with this. So this is one slit, and the width of the slit, I say it is A. This is the rays which are moving, this is propagating parallelly in toward C. We have placed one screen at some distance toward C. Okay, and this point is toward P. Because rays are deviated, waves are deviated, and they are moving toward the P. This makes angle theta with this MC. MC સાથે theta angle બનાવેલા rays આપણે waves લીધા છે. Theta may be anyone, maybe small, maybe large one. At present, theta is variable. Okay. LM is A. So if you see it on the screen, then you will find dark, bright bands. And why we get this dark and bright bands, that we want to explain. ये આપણે explain કરવાનું છે. Of course, dark is corresponding to destructive interference and bright is corresponding to constructive interference. So beginning I told you, to explain diffraction we need interference. Without interference you cannot explain the diffraction at all. Okay. So suppose the distance LM here, LM is equal to A. ln is equal to A. The width of the slit is A. Okay. So NQ is equal to A sin theta. Okay. So I take point P here. So when waves reach at point P, what is the path difference between the 2 points which are at the end, L and N. So the path difference between two waves emitting from L and N at point P is equal to, we can say, A sin theta. Path difference is A sin theta because LM is parallel to the wavefront. So all the points on the slit, I take suppose all the points, they are in same phase. All the points on the slit are in phase. But when this ray emitted from L and emitted from N going toward the P, then this wave has to travel more distance by NQ. L and N both are in same phase, but this traveled more distance NQ, and because of that there is a path difference. Okay, so if A sin theta, okay, if we take 2 points on slit M1 and M2 at separation Y, then path difference કેટલો થશે? What is the path difference? Then path difference would be Y sin theta. Understood? So wave is emitted from here, this has to travel this much distance and this has to travel this much. So if you calculate it, then it comes out to be Y sin theta. At distance cover if the separation is Y. Okay, and M1 and M2 both are variable, so Y distance રહેલા છે તો Y sin theta. And if you take theta is small, then in both the case we can write is equal to A theta. Here also I write Y theta if theta is small, and theta સાનું જ હશે. So if you want to calculate what is the intensity at point P પાસે intensity કેટલી હશે, then what I should do, I have to calculate intensity of the wave emitted from all the points of the slit. Slit ઉપરના દરેક point માંથી emit થતા wave ની મારે intensity લઈ લેવાની, and then I have to add it. પછી મારે શું કરવાનું? Add કરવાનું. Considering phase difference ની સાથે મારે calculation કરવાની. And that is very tough job. We are not doing that job. It is Fresnel has done, I think. Yes, Fresnel has done this job. He has calculated intensity at point P because of the wave emitted from all the points of the slit with consideration of phase difference. But what we are going to explain, that is logical ways. આપણે logically explain કરવાના છે P પાસે intensity કેટલી આવશે. Okay. So don't worry, we are not doing that calculation because I am also not knowing. So if A theta is equal to n lambda, if A theta is equal to L lambda, then what will happen? Theta, first I write lambda only. Okay, first I write lambda only. Then theta will be equal to lambda upon A. Lambda upon A. Okay. Sorry, first I focus on center point. Then I will go for that. Okay. First I focus on this point C. So this point is toward the C. So all the waves emitted from all these points between L and N, when reach at C, okay, they have path difference 0. L માંથી આવેલું અહીંયા આવશે, અહીંયાથી આવેલું અહીંયા આવશે. Both waves travel equal distance, so path difference 0. I take one more point here, I point here. Again, path difference is 0. I take here and here, straight one, Paschudhiva path. In short, we can say that all the waves emitting from all the points between L and N gives path difference 0 at point C. So we get maximum intensity because the construct difference called central maxima. તો તમે જ્યારે ઓબ્ઝર્વ કરશો તો શાર્પ એજ હોય તો સામે એક તમને સેન્ટ્રલ મેક્સિમા મળશે. ઓકે, we get central maxima. So C is the central maxima. Okay, now if A theta is equal to n plus half lambda, where n is equal to 1 plus or minus 1 plus or minus 2 and so on. So what we get, theta is equal to n plus half lambda upon A. Okay, I take theta as such, P point હું એવું પસંદ કરું છું, so it gives theta is like that. Theta is variable, I can take P up or down anywhere. So theta is such that P is, we have selected such that theta is equal to this one. Okay, so in that case we get maxima. Why any other explanation આપવાનું છે? And if A theta is equal to n lambda and theta is equal to n lambda upon A, we get minima. Why we get minima and why we get maxima, એનું આપણે explanation દેવાનું છે. આપણે અગાઉ એડવાન્સમાં કહી દીધું છે. But why it is so? First I explain this part. Okay, so we explain minima. For that I take this copy, I take copy of this and I paste on other one. Oh, sorry. Okay, so this is the favor figure. So I take theta is equal to n lambda upon A, and first I take n is equal to 1. We take n equal to 1, so we get theta is equal to lambda upon A. Now what is happening now? Let us see. Lambda upon A, and we are explaining minima. કદાચ ક્વેશ્ચન હોય તો we are explaining minima. ક્યારે મળે એનું આપણે explanation આપી રહ્યા છીએ. Look at here. I take this slit, complete ln. So what is nq? Theta is as we nq is equal to what? So nq is equal to a sin theta. Theta is small, so a theta and is equal to lambda. Okay, so nq is equal to lambda. So what is happening? The wave emitted from L and M. L માંથી નીકળ્યું છે અને M માંથી બી નીકળ્યું છે. તો આને એટલું ટ્રાવેલ વધારે કરવું પડશે. This wave has to travel more distance this much. Let us say it is Q1. Okay. The wave emitted from L and M gives path difference lambda by 2. Okay, lambda by 2. Yeah, this is lambda. So this is lambda by 2 because M is the midpoint. Okay. M is the midpoint. So destructive interference is taking place. At point P. P અત્યારે આપણે આનાથી ફિક્સ કરેલો છે theta is h. Okay. Likewise, I take M1 that is between LM and M2 between MN. Likewise, 2 points M1 that is between L and M and M2 that is between M and N. 2 points M1 and M2 gives path difference lambda by 2. એક પોઈન્ટ હું અહીંયાથી પસંદ કરું, જેટલા ડિસ્ટન્સ અહીંયા છે એટલા ડિસ્ટન્સ અહીંયા, તો એ વચ્ચેનો પાથ ડિફરન્સ કેટલો થશે? એટલે કે M1 M2 કેટલું છે મારું? M1 M2 is equal to Y is equal to A by 2. We select 2 points which are at the separation A by 2. Okay. So path difference is lambda by 2. Path difference because અહીંયા આપણે લીધું છે ને Y theta. So if it is A, then lambda. If it is A by 2, then lambda by 2. So path difference is lambda by 2. સમજ આવ્યું? If it is A જેટલું હોય તો કેટલું? તો lambda. તો A by 2 એ કેટલું થાય? Lambda by 2. Okay, M1 M2 is equal to A by 2. Okay. So point P will be at minimum intensity called first minima. Similarly, we get one point down also corresponding to -1. If I put -1 because n has both the value plus and minus, I take -1. If I -1, then below the C. તો અહીંયા પણ એક મને મેક્સિમમ મિનિમમ મળશે. Similarly, I get minima down also at equal distance from C. Equal distance from C. તમને બંને જગ્યાએ મળશે. સમજો? If I take 2, n is equal to 2, then I get minima here. Similarly, I get minima here also at equal distance. Okay. So, that's the minima no explanation. Why we get minima on the screen? Why we get minima? If I take n is equal to 2, then I have to divide this slit into 4 parts. So half part is cancelled, 1/4 1/4 is cancelled, 1/3 again 1/4 1/4 is cancelled like this. I divide into 4 parts. So આ ભાગ આનાથી કેન્સલ થઈ જશે અને આ ભાગ આનાથી કેન્સલ થઈ જશે. અત્યારે શું છે? આ બે પોઈન્ટ લીધા છે અને આ ડિસ્ટન્સ કેટલું લીધું આપણે? લેમ્બડા. હવે આ 2 લેમ્બડા થશે. તો એને 4 ભાગ કરું તો શું થશે? અહીં વચ્ચે લેમ્બડા બાય 2 હશે, લેમ્બડા બાય 4 થશે and so on. You can do it. લેમ્બડા સમજમાં આવ્યું? So if it is 3, then I have to divide slit in 6 parts. તો 6 ભાગ બનશે. એને બબ્બે પેર બનાવી નાખવાની. 2 will cancel, 2 will cancel, 2 will cancel. So you get minima. Upside as well as downside. So this is the explanation for the minima. Okay, now we go for maxima. Now we explain maxima. So to explain maxima, what is our condition? A theta is equal to n plus half lambda, and therefore theta is equal to n plus half lambda upon A. This is the condition for the maxima. We take n equal to 1. I can take minus 1 also. So theta becomes 1 means 3 lambda upon 2A. Theta is such that it becomes theta lambda upon 3 lambda upon 2A. તો આ જે પોઈન્ટ છે થોડુંક આનાથી ઉપર હોવું જોઈએ, જે અહીંયા મેં સિલેક્ટ કર્યું એના થોડું ઉપર હશે. તો શું થશે? This is not lambda. It is 3 lambda by 2. It is 3 lambda by 2. કેટલું થશે આ? NQ is 3 lambda by 2. So path reference now. Reference between the waves emitted from L and N, emitted from L and N, is NQ is equal to A sin theta is equal to A theta is equal to A 3 lambda upon 2A, because it is, so we get 3 lambda upon 2. So definitely પહેલા જે એંગલ હતો એનાથી મારે થોડો વધારે કરવો પડે તો તે વધવાનું છે. તો આ જે NQ મારું મોટું થઈ જશે. Now I divide this slit into 3 parts. Now I divide slit in 3 parts. Look at here. Text માં બધું just explanation આપ્યું છે. 1 2 3. Okay, 3 parts. This way going this side, here going this side, and this side. Now see, this is toward P. આ શું છે? It is A. And I draw this perpendicular. This is Q, this is L, this is N. And this is 3 lambda by 2. So what is this? Lambda. And what is this? Lambda by 2. Text માં figure draw નથી કરી, પણ હું તમને સમજાવું છું. તો આમાંથી વેવ એમિટ થયું, અહીંયાથી થયું. તો એની વચ્ચે what is the phase path reference? લેમ્બડા. તો તમે આટલા ભાગને આને હું નામ આપી દઉં, suppose it is N1, LN1. તો L1 is similar to the first case થઈ ગયું. LN path reference કેટલો હતો? લેમ્બડા. And here path reference કેટલો થઈ ગયો? લેમ્બડા. તો આટલો ભાગ છે એ પ્રીવિયસ ભાગ જેવો થયો. It is very similar to that one. Again you can explain that this is cancelled with this one. 2/3 part છે. This is 2/3 part and this is 1/3 part. Sorry. So 2/3 part of the slit is very similar to the previous case. So the effect is cancelled out. But still this effect is not cancelled out. So we get some intensity. So if we divide slit in 3 equal parts, then 2/3 part, then effect of 2/3 part of the slit is cancelled, while 1/3 part of the slit is giving intensity at P. So we get some intensity at point P corresponding to theta is equal to 3 lambda upon 2a. This point is called first maxima. Okay, and the first maxima is above the first minima. So here at the center maxima, then first minima, then first maxima, then what you will get? Second minima, then second maxima, likewise down, first minima. Okay, but intensity here is less than the center maxima. The intensity of first maxima will be less than central maxima. While increasing the order of maxima, intensity decreases rapidly. Intensity decreases very rapidly. In contrary to that interference pattern. In interference pattern, all the intensity equal, width also equal. તો અહીંયા એવું હોતું નથી. So what you will observe on the screen, that is also important. So if you see the screen, તો screen ને હું આડી લઈ લઉં છું. This is my screen, suppose. This is my screen. Okay. So on the screen you will see bright band at the center. This is center corresponding, sorry. This is center. And I say suppose this is the center. Then I will get like this. So what I want to show is that I want to understood what I want to show. आप समझी लिया છે કે હું શું સમજાવવા જઈ રહ્યો છું. Sorry. I hope કે બે સરખી હોય. So center, this is your center maxima. અહીંયાથી અહીંયા સુધી center maxima. This is first minima. This is first minima. Bay side. This is first maxima. Then second minima. તો તમે જો આની કરતા આની ઇન્ટેન્સિટી મેં ઓછી કરી દીધી છે, એની કરતા આની ઓછી કરી દીધી છે, આની કરતા આની ઓછી કરી દીધી છે, આની કરતા આ બે સરખી જશે. This both are equal. સેન્ટ્રલ મેક્સિમાની width ડબલ છે બધા કરતા. આવી રીતે જોવા મળશે. This is central maxima. So width of the central maxima is double than the others. One thing એ યાદ રાખવાનું છે. અને જો હું એનો ગ્રાફ પ્લોટ કરું તો ઇન્ટેન્સિટી કઈ રીતે વેરી થાય એની થોડી વાત કરી દો. So here intensity is maximum and it becomes zero. It becomes 0 like this, then again increases, decreases, like this. Can you imagine now? Sorry. So intensity is maximum at the center, then it decreases very rapidly. આની intensity આટલી છે, આની intensity આની maximum છે. And width is double than the others. કેટલી width હોય? આની કેટલી width હોય? So you can find lambda d upon d only. અહીંયાથી અહીંયા સુધી distance lambda d upon 2d you can show also. And this is 2 times. This is 2 times. તો આ જે point છે અને આ point છે એ તમારી સેન્ટ્રલ મેક્સિમમ આપશે. એટલે ટૂંકમાં we can say that this is your અહીંયાથી અહીંયા સુધીનું જે મારું છે એ મારું સેન્ટ્રલ મેક્સિમમ છે અહીંયાથી અહીંયા સુધીનું. So distance between two up minima and down minima is the width of the central maxima. Distance between two મિનિમા, એક ઉપરનું એક નીચેનું મિનિમા, એની વચ્ચેના શું કહેવાય છે? સેન્ટ્રલ મેક્સિમા કહેવાય છે. અને આની વિડ્થ કેવી છે? સેન્ટ્રલ મેક્સિમાની ડબલ, બીજાની એનાથી હાફ. ઇન્ટેન્સિટી ઇઝ મેક્સિમમ. તો આટલી વાત આપણે, તો ઇન જનરલ હવે આપણે એમ થઈ ગયું કે મિનિમાની કન્ડિશન શું છે? વોટ ઇઝ ધ કન્ડિશન ફોર મિનિમા? તો કન્ડિશન ફોર મિનિમા થીટા ઇઝ ઇક્વલ ટુ a n lambda upon a. N lambda upon a, and condition for maxima theta is equal to n plus half lambda upon a. N is equal to plus or minus 1, plus or minus 2, and so on. N is equal to plus or minus 1, plus or minus 2, and so on. Central maxima આમાં ધ્યાનમાં લેવાનું નથી, central maxima અલગથી વાત કરવાની છે. Okay. So this is a pattern of the diffraction pattern. Okay. અહીં સુધી રાખું છું. Thank you.